So I want to share with you this integral question that I found pretty interesting. It's the integral from 0 to pi over 4 of the natural log of 1 plus tangent of x, of course, dx. All right, and believe it or not, we could evaluate this just using techniques from Calc 1. So the first thing we're going to do is use the u substitution. U is equal to pi over 4 minus x, so du is equal to negative dx. Okay, and you could check our bounds would switch from pi over 4 to 0 of natural log of 1 plus tangent of, well, x would be pi over 4 minus u du, and I lost the negative sign. Okay, and so we have a negative, which means we could switch the order of the bounds, so 0 to pi over 4 of natural log of 1 plus tan of pi over 4 minus u du. Okay, and believe it or not, this is a little simpler than what we started with. So what we're going to do now is we're going to use the trig identity that tangent of alpha minus beta, okay, so the difference of two angles, like we have here, is equal to tan of alpha minus tan of beta over 1 plus tan of alpha tan of beta. Okay, so using this identity, here alpha would be pi over 4, so tangent of alpha is just 1, and beta would be u. Okay, so our integral becomes the integral from 0 to pi over 4 of ln of 1 plus 1 minus tan of u over, again, tan of alpha, tan of pi over 4 is just 1 over 1 plus tan of u du. We could get a common denominator, and this becomes integral from 0 to pi over 4 of ln of 1 plus tan of u over 1 plus tan of u plus 1 minus tan of u over 1 plus tan of u du. Okay, combined like terms, our numerator is 1 plus tan of u plus 1 minus tan of u. The numerator is just 2. Okay, and we could break this apart using log rules. So this is equal to the integral from 0 to pi over 4 of ln of 2 du minus the integral from 0 to pi over 4 of ln of 1 plus tan of u du. But this is exactly the integral we started with. The only difference is we have the letter u instead of the letter x, but it doesn't matter because we have the same bounds. Okay, so we could add this over to the other side, and we get 2 times the integral from 0 to pi over 4 of ln of 1 plus tan of x, 1 plus tan of x, dx is equal to the integral from 0 to pi over 4 of ln of 2 du. This is just a constant, right? So the integral of a constant is just, well, you find the length of the interval and multiply it by that constant. So this is equal to pi over 4 ln of 2, and then we divide by 2, and we get the integral. So the integral we care about When we divide by 2, we get pi over 8 ln of 2. And it's simple as that. I thought this was pretty neat, a kind of neat trick. I know the other day I asked what kind of content you all want to see, and a few of you said integrals, so I thought this would be a good one to share. All right, let me know any thoughts you have in the comments, and I'll try to get back to as many of them as I can. All right, bye-bye.